So after reviewing factoring in 8.6 and 8.7, today we're going to review 8.8, which is rational expressions. Again, this is all a review from beginning algebra, a review of rational expressions. When we say rational expressions, so we're going to define what we mean by rational expression. We're going to talk about simplifying rational expressions, multiplying and dividing rational expressions, adding and subtracting rational expressions, and then we're gonna learn how to solve equations with fractions or rational expressions. Okay, so there's a lot in this section. It's all review though. Okay, so let's define rational expression. A rational expression, from the word ratio of expressions, is a ratio of two, not just any expressions, they have to be polynomials. Okay, so if you take a polynomial divided by another polynomial, we get rational expression. As long as that's a polynomial, and that's a polynomial as long as q is not 0. The denominator cannot be 0. So we have rational expression, and then we have, so for example, x plus 2 over x minus 2 is a rational expression. And we have rational function. So there's expression and there's function. Like if we have rational expression, it's p over q. If we have rational function, it's f of x equals p over q. Okay, expression, function. So when we say rational function, it's going to equal y or f of x. So the rational function f of x equals p over q. If you have that, so it's a function. So what's the domain? Domain of this function is all real numbers. Remember, any x will be in the domain as long as when you plug it in, you can get a y value. For x to be plugged in and get a y value, we get all real numbers x such that q is not 0. Because if q is 0, it's undefined. Okay, a fraction is undefined when its denominator equals 0. So let's explain that with some examples. So what's the domain of f of x equals 8 over x minus 1? So we know the domain will be all real numbers except where q equals 0. So if q equals 0, what would happen? If x minus 1 equals 0, x equals 1. So everything else is in the domain except 1. So the domain of f in this case, it's all real numbers except 1. Negative infinity to infinity except 1. So we write negative infinity to 1 and then 1 to infinity. Sorry for the mess. Okay, or you can just write x does not equal 1, but I prefer this. You gotta get used to the interval notation. Another example, number 30. What's the domain of x squared plus 36 over x squared minus 36? Again, to find the domain, we start out by setting the bottom equals 0. This can be factored as x minus 6, x plus 6. So x minus 6 equals 0 when x equals 6, x plus 6 equals 0. So the domain is all real numbers except negative 6 and 6. So we're gonna, if you look at the number line, that's 6, that's negative 6. So everything except these two. So we have the interval from negative infinity to negative 6, negative 6 to 6, and then 6 to infinity. So we're gonna write this as negative infinity to negative 6, union negative 6 to 6, and then union 6 to infinity. Alright, so this is how we find the domain. How do we simplify a rational expression? So now we're back to expressions, not functions. Simplify a rational expression. We want to completely factor, if possible or if needed, the numerator and denominator of that expression, and then we cross out all common factors. And you can see how important factoring is. So we're going to recall all the factoring techniques that we learned previously. So let's look at 36, page 697. How do we simplify 15a to the 5, b to the 4 over 21 a to b5? No factoring is needed because there's no pluses or minuses. So we reduce the numbers, we subtract the exponents. Remember, if we have a to the m over a to the n, it's a to the m minus n, okay? So the 15 and 21, they're reduced by 3, so it's 5 over 7. a5 over a2 is a cubed, b4 over b5 is b to the negative 1. We move this down. We don't like negative exponents, so that's what we get. So we didn't have to factor here. Now if you look at the next examples, simplify x squared plus 3x plus 9 over x cubed minus 27. So we get a factor, it's pluses and minuses. A trinomial can be factored if you can find two numbers that have a product of 9, a sum of 3. Product of 9, it's 1 and 9 or 3 and 3. Sum here is 10 and sum there is 6. So this is prime, can't factor it. Let's look at the bottom. This is the difference of cubes. So we're going to factor it as binomial times trinomial. We cover that, x and 3, you square, multiply, and then square again. So same, opposite, always plus, and good for us. Now we can cancel all this out. And the answer is not x minus 3. It's 1 over x minus 3. Be careful, okay? Example 2, we have 2x squared plus 2x minus 12 over x cubed plus 3x squared minus 4x minus 12. Okay. There's a lot of factoring to do. If you look at the numerator, we can pull the 2 out first. So it's x squared plus x minus 6. And then product is negative 6, sum is 1. So it's x plus 3, x minus 2, and we pull the 2 down. At the bottom, we have 4 terms. So we're going to do grouping. We pull out x squared, and then we pull out the negative 4, x plus 3, and it's going to be x plus 3, x squared minus 4, and we know x squared minus 4 is the difference of two squares, so it's x minus 2 times x plus 2. Once everything is completely factored, then we start crossing things out, and whatever is left is going to be your answer, which is in this case 2 over x plus 2. Alright, so we've done domain of rational functions, and now we just finished simplifying rational expressions, and now we're going to talk about multiplying rational expressions. Multiplying rational expressions. So to do that, we completely factor all numerators and all denominators. Everything has to be factored if possible. Once everything is factored, then you cross out all common factors. You can cross out any common factor between any numerator and any denominator. Okay, it has to be numerator versus denominator. And then the last thing you want to do is multiply. Once everything is factored and crossed out, then you multiply straight across. P over Q times R over S. But that's after you've reduced, okay? PR over QS. Page 697, number 50. So you can see nothing can be done without knowing all the factoring techniques. A plus 6 over a squared minus 16 times 3a minus 12 over 3a plus 18. All right, so let's see what we can factor. A plus 6 is prime. That's the difference of two squares. A minus 4, a plus 4. 3a minus 12, we can pull out the 3 as a common factor, and same at the bottom, a plus 6. And now we can cancel common factors out, a minus 4, the 3. So we have nothing left on top, which is a 1, and then at the bottom, a plus 4. All right, 52 from page 697. 2p squared minus 5p minus 3 over p squared minus 9 times 2p squared plus 5p minus 3. Okay, 5p plus 2. So factoring general trinomials, remember we did this by grouping. If you forgot, go back to the handout and brush up on this. It's 2p plus 1, p minus 3, difference of two squares, p minus 3, p plus 3. Same thing here, 2p minus 1, p plus 3, and 2p plus 1, p plus 2. Once it's factored, it's just easy crossing things out. P plus 3, so we're left with 2p minus 1 on top, p plus 2 on the bottom. So see, it's all about factoring. You don't know factoring, you're not going to be able to do this. So dividing rational expressions, dividing rational expressions. In dividing, you're gonna multiply by the reciprocal, divided by r over s. You multiply by the reciprocal, so it would be p over q times, you flip that, s over r. And now once it's that, then you know what to do. You factor, you cross out common factors, and you multiply straight across. So it's an extra step that has to be done first. 60, page 697. A squared minus 9 over a squared minus 49 divided by a plus 3 over a plus 7. Since it's division, we're going to flip it. A plus 7, a plus 3, and that stays the same. And now it's a multiplication question. So the first top is difference of two squares, a minus 3, a plus 3. Same with the bottom, a minus 7, a plus 7. And these two are prime. Nothing can be factored. A plus 3 cancels out, a plus 7 cancels out. And you have a minus 3 over a minus 7 as the final answer. Alright, let's do 64 from page 698. 8y squared minus 14y minus 15 over 6y squared minus 11y minus 10 divided by 4y squared minus 9y minus 9 over 3y squared minus 7y minus 6. So the first thing I want to do is flip it. 3y squared minus 7y minus 6. You flip this. And then 4y squared minus 9y minus 6. We keep that as is. 6y squared minus 11y minus 10. Again, factoring general trinomials. I'll just give you the work. You can go back if you forgot and see how we did it. This is 3y plus 2, 2y minus 5. This is 3y plus 2, y minus 3, 4y plus 3, y minus, oh, this should be a 9, sorry. Please fix that. Okay, it's a 9. Y minus 3. So 4y plus 3 cancels out, 2y minus y, 3y plus 2. Everything cancels out. So you have 1 over 1, which is just 1. It's not a 0. 0 would be wrong. Okay. So we've done simplifying adding and subtracting. Next, I'm sorry, multiplying and dividing. Next, we're going to talk about adding and subtracting. Adding or subtracting rational expressions. If they have same denominators, that's the easier case. So say you have a over c plus b over c. Same c, you just add the tops and divide by the bottom. Same thing with subtraction. Subtract the tops over the same bottom. Then you have to simplify if possible, okay? Sometimes you can simplify it, others you can't. For example, you have 4 over a plus 4 minus 2a over a plus 4 plus 3a over a plus 4. Since it's adding and subtracting, you want to check, do we have the same bottom? We do, so it's all going to have the same denominator, a plus 4, and then 4 minus 2a plus 3a, which would be 4 plus a over a plus 4. A plus 4 and 4 plus a are the same, so the answer is 1. Example 2, where the denominators are the same. Now remember, when we're timesing or dividing, the denominators don't have to be the same. When we're adding or subtracting, they must be the same, otherwise we can't add or subtract. Minus x plus 3 over x squared plus 13x plus 12. So as soon as I see subtraction, then I check the bottoms, they're the same, good for me. So I'll just write the bottom, x squared plus 13x plus 12, 2x plus 4, this guy comes down, minus, that's a problem, be careful. When you have a minus followed by a fraction, this minus has to go through every term on top, so it's minus x minus 3. Okay, that's a very common mistake, and you don't want to fall into that. 2x minus x is x. 4 minus 3 is plus 1. We can factor the bottom because we could probably simplify 12 and 1. And it does simplify into 1 over x plus 12. You always want to simplify your answer. Now, what if the denominators are not the same? Okay. And I have a handout for that. I don't want to write down all these steps, okay? So, adding and subtracting rational expressions with different denominators. Here, so in order to do that, there's a handout, again it's on D2L for you, adding and subtracting fractions with different denominators. You can see the first step says determine the LCD, okay, the least common denominator, and I have the steps on top for finding the LCD. Let me just zoom out so you can see. Okay, to find the LCD, you want to factor each denominator completely. Any factors that occur more than once should be expressed as powers. Okay, so for example, just to explain that, if you're doing, say, 2 over x squared minus 4x plus 4 plus 3 over x minus 2, if you want to factor that, it's x minus 2, but it should be expressed as a power. That's what they mean by that, okay? List all different factors other than one that appear in any of the denominators. When the same factor appears in more than one denominator, write that factor with the highest power. So you're gonna, to find the LCD, you're gonna look at each factor. There's only one factor, x minus 2. X minus 2 appears on both of them. You list the one with the highest power. Why the highest power? We are not finding the greatest common factor. If we were, it would be x minus 2. Since we're looking for the least common denominator, that's a multiple. To be a multiple, it has to include the highest power, okay? and the least common denominator is the product of all these. That's finding the LCD. After you find the LCD, then you want to build each fraction into an equivalent fraction with the LCD as its new denominator. Then once you have the same denominator, then you add or subtract the numerators and maintain the LCD, and then you can simplify. So find the LCD by factoring all the denominators, and then include in the LCD each factor, whether it's common or not. And if the factor shows up more than once, you pick the one with the highest power. Okay, so let's practice that. One over x plus x over x minus 2. So nothing to be factored. X is prime, x minus 2 is prime. To find the LCD, you bring each factor. X is a factor, x minus 2 is a factor. So you times them together. That's going to be the LCD. Okay, then you build each fraction. You're going to times the first fraction by what's missing. Compare it with the LCD. It's missing x minus 2 plus the second one is missing x. Going to times by x. Okay, so you get, so now we have the same denominator, so we make them one fraction, x minus 2 times 1 plus x squared, which is x squared. It's a trinomial. It's worth trying to factor it in case we can reduce. So product of -2, sum is 1, plus 2 minus 1. And I was hoping to reduce it, but we can't reduce anything. Alright, page 698, number 80. Page 698, number 80. 7 over x plus 3 plus 4x over x plus 6. Again, the LCD is x plus 3 times x plus 6. So we're going to times the first one by x plus 6, top and bottom. And the second one by x plus 3, top and bottom, to get the same LCD. So this is going to be 7x plus 42 over x plus 3, x plus 6, plus 4x squared plus 12x over x plus 3, x plus 6. Now if you combine the tops, you have the same bottom, so we can write one fraction. You have 4x squared plus 19x plus 42, and this is prime. Okay, this doesn't factor. Alright, I'll show you one more example from there, and then we'll do the last part. 2 over x minus 2 plus 3 over x plus 2 minus x minus 1 over x squared minus 4. The denominators are different, but we could factor the last one, x minus 2, x plus 2. So the LCD is x minus 2 has to be brought down, x plus 2 has to be brought down, x minus 2 already brought down, x plus 2 already brought down. So it's that. So we're going to times the first fraction by x plus 2, the second one by x minus 2, and the third one already has what it wants, which is x minus 2, x plus 2. So this would be 2x plus 4 over x minus 2, x plus 2, plus 3x minus 6 over x plus 2, x minus 2, minus x minus 1, x minus 2, x plus 2. So now we're going to put them together with one fraction, with the LCD at the bottom, and bring everything else down to x minus 4 plus 3x minus 6. Now that's the problem right there. So it's going to go through this. It's minus x plus 1. Be careful, okay? It's a very common mistake. So we have 2x, 5x, minus x is 4x, negative 4, negative 10, plus 1. Oh, it's a plus 4. I'm sorry. Why did I have it? That's a plus. Okay. So 4 minus 6 is negative 2, plus 1 is minus 1. Now it looks right. Okay. I just had a mistake. This was a plus. I brought it down as a minus. So please fix it. Alright. Last is solving equations that contain rational expressions. So if you have an equation with fractions, basically, okay? Equations that contain rational expressions. Again, we follow steps for doing this. I'll just show you an example, a simple one first. 7 over 5x minus 1 over 2 equals 5 over 6x plus 1/3. Remember, the denominator should never be 0. You always have to watch out for that. In this case, 5x cannot be 0 and 6x. So keep in mind that x cannot equal 0. That's what the domain is about. Again, there's a handout about solving rational equations. So you want to first eliminate all the fractions by multiplying by the LCD. The LCD of 5x, 2, 6x, and 3 is going to be 5, 6, 2, and 3. It's 30. And then we have to include x. So we're going to times everything by 30x, left, right, and right side of the equal sign. So when we do 30x over 1 times 7 over 5x, what do we get? 5x cancels that, you get 6. 6 times 7 is 42. You do 30x over 1 times 1/2, that's 15x, equals, when you do 5 over 6x times 30x over 1, 6x, that's going to be 5, it's 25. And when you do 1/3 times 30x over 1, that's 10x. Okay, and then you want your letters on one side, your numbers on the opposite side, so minus 10x. So you get 42 minus 25x is 25. Move the 42 over. Negative 25x equals 17. Divide by negative 25. It's negative 17. So it's 17 over 25 because the minuses cancel out. Let's look at 96, page 698. 96, page 698. 3 over 2x plus 4 equals x minus 2 over 2 plus x minus 5 over 2x plus 4. Since we have an equation, we can times by the LCD. If it's an expression, we cannot do that. So we want to factor the 2 out first. So we have 3 over 2 times x plus 2 equals x minus 2 over 2 plus x minus 5 over 2 times x plus 2. So we want to times by 2 times x plus 2 to get rid of all the fractions over 1. And then times by each one of these, so 2, so I'll just do it right here, 2 times x plus 2 over 1, 2 times x plus 2 over 1. That cancels all out. Remember here, x cannot equal negative 2. Keep that in mind because x plus 2 equals 0 when x is negative 2. That's not in the domain. So any x will work except that. So we get 3 equals, the 2's cancel out. X plus 2 times x minus 2 is x squared minus 4 when you FOIL it, plus x minus 5. So you get 3 equals x squared plus x, negative 4 minus 5 is negative 9. 0 equals x squared plus x minus 12. You can factor that out, x plus 4, x minus 3. So we get negative 4. As long as it's not negative 2, we circle it. If it's negative 2, we cross it out and we say that is not a solution. Alright, so that's it for, there's more examples you can work out, but that's it for 8.8. We still have 8.9 and I believe A2, Appendix 2 to do next time.